So, thank you for the small claps. Also, thanks, Dan, for giving us this opportunity to chat up here. He makes the talk sound really boring. I apologize if it is. I'm firmly of the opinion that security is a risk management function. And at the end of the day, if you're not thinking about risk, then what are you actually thinking about? So first off, I'm on the security team at Coinbase. My team does just about all of the preventative work. So application security, infrastructure security, something that we're starting to call BlockSec because ASIC sounds bad, which is asset security, and some amount of security architecture. Also, so that I can justify my ability to fly out here to New York since we're SF based, somebody please go click on that link and like submit a job posting. I don't care which one, just something in security and say you found me here. But as you can guess, there's a lot of work to do. And particularly what's becoming more and more interesting for us is blockchain security. Before we get super deep into what blockchain security means, I'd like to spend a little bit of time talking about Coinbase as a custodian. So our primary business, and I wrote this down, is to enable bidirectional transfer of value between cryptocurrency and traditional currency. Said another way, we want to make it really easy to buy and sell crypto. Turns out that if you want to buy and sell or move money around, you have two core security concerns that kind of come up. The government cares a lot about who and what is interacting with your systems. Those are all the KYC, AML requirements. KYC is know your customer. AML is anti-money laundering. On behalf of the government, we basically collect boatloads of identities, and we have to maintain them for like 7 years. That's like probably my biggest headache. Those things, if and when they leak, you never get them back. The second thing is people tend to use exchanges as their custodians for currency. You'll set up an account, you'll buy and sell, whatever you want, turn your USD into USDC, turn your USD into Bitcoin, Ethereum, so on, and just leave it on platform. It turns out that when you leave it on platform, I don't earn any money for it because we're not doing any kind of lending out of it, right? It just sits there, and it just accumulates risk over time. The money just sits there, people want to take it. The cool thing about the blockchain is transactions are more or less final. If we lose it, it never comes back. So you can guess, my team has two key problems. One is key management. This currency nowadays is just private keys. We all know that key management is like the fundamental problem for when you build a secret system, which is at the end of the day, where do you keep the master key? The second thing is access control and access management. Who gets access to what? How much do they get access to? What do you do? Turns out we can boil that. Sorry, I skipped way too far ahead. We've done quite a few talks already on key management. We have a system called Nox. There's this whole backend stuff, blog posts on cold storage, our new cold storage systems and whatnot. We haven't talked a lot about access management because that's been beat to the ground by NIST, like about 10, 15 years ago. So I'm going to talk about the next set of problems here, which is around blockchain and asset security. So assets, obvious user fund impact, right? That's straight up, we treat it as money. It should basically be money. If soon as a sovereign country accepts it as a currency, we'll actually get to treat it like money. But until then, we're going to call it assets. Because, and this is again, for the most part, most blockchains don't really care about user data. Turns out, Stellar cares a little bit about user data, how they want you to do like some of their back office stuff. But at the end of the day, most blockchains are just transactions on a network. So when we talk about user funds impact, I boil that down to one word that I made up because I couldn't find any other word that describes it, which is custodiability. Again, our key purpose is store assets for users because that's what they want us to do, which means that any asset that we support on our platform, we need to be able to custody, right? We need to be able to maintain it. So let's talk about kind of custodial risk, custodiability risk. The first thing that I recommend you do when you're given a new problem space is build a framework. We recently had some tweets go on around us trying to trademark build, whatever that is pronounced, but we decided not to. What is the purpose of this framework, right? You want to evaluate any given asset against any other asset and build like your baseline of what's acceptable for us to be able to maintain. We also want it to be auditor friendly, so we gave it a very pretty name, DASIF. Unfortunately, I would love to have released DASIF to the wild right now. It makes it a lot easier for like many companies to look at assets the same way we do, but we're still in point releases. But again, the goal for DASIF is let's build a framework that says, given a given asset, how likely is it that we will not be able to maintain custody of it? Another way to think about custodiability is our ability to just account for it, which is once it enters the system or once people think they've sent it to us, how do we know it's actually still there? When we send it to somebody else, how much did we send? How did we send it? If it is sitting in one place and we don't think anybody's touched it or moved it, but somehow it moves, our custodiability is impacted. So we break down kind of the DASIF into two sets of categories, some objective, things that you can actually measure and look at, others subjective, things you can't measure but we have a gut feeling for. Most of you people who do security know that you don't get paid for the objective stuff, you do get paid for the subjective stuff, you also get fired for the subjective stuff. That's your risk evaluation, we shouldn't do this. So let's talk about a couple pieces of the DASIF itself. The first obvious thing that we can look for is, has anybody else done any sort of security analysis on this work? This could be source code review on nodes. This could be protocol level analyses on, let's say, IOTA's Tangle, right? Like, does anybody actually understand what these security primitives are in that system? Have they done any rigorous sort of work? Similarly, when you come to smart contracts, we're like, has anybody looked at the smart contracts, right? Has Trail of Bits or QuantStamp or OpenZeppelin or so have you, like, published a report that says, yeah, this code seems fine? The second thing that we have to look out a lot for is the supply chain of the software itself, right? At the end of the day, regardless of what the white paper says, the node implementation of any given blockchain is the truth of that protocol. So an obvious example of this is a couple of months back, Parity had a bug, which allowed for transactions that were unverified or unverifiable to be accepted as valid transactions. It doesn't matter what the white paper says or what all of the shills are talking about any given currency. If the node software isn't fine, right, the core accounting won't work. Your wallets won't work. Like how things move around, it doesn't matter. The other thing we're looking for here, and this is a bit more interesting with Ethereum smart contracts, is just that deploy supply chain, right? When somebody writes code, puts it into GitHub, and says, here's our deployed Ethereum smart contract, can we go one for one and look up what it actually is on the blockchain, right? When somebody gives us an address and says, this is the address at which a given contract exists, is that actually the address that's representative of the code that got audited? How many upgrades has it gone through between when somebody looked at it to its current state? And when it upgrades, are we going to have any idea that it's upgraded beyond watching Telegram chats or looking on tweets? I talked a little bit about the node and wallet implementation, but this is, again, like, I'm going to reiterate that one matters a lot, right? Your node is your view of the world. If your node is telling you that transactions A, B, and C have happened, but nobody else believes that they've happened, you're off doing your own thing. You've got your little side chain going. The idea of what crypto is just doesn't matter anymore. Similarly, like if your wallet implementations aren't good, right? I say I want to move money from account A to account B, and the wallet does something absolutely else. I've got nothing to work off of here, right? I'm re-implementing from protocols something that may change at an arbitrary point. For us, what we do is we just go gather all this information, right? The first thing I want to be able to say is, how quickly can I turn around from a given asset the likelihood that there's going to be any kind of vulnerability or risk? These are some pieces of it. We've got like a much larger framework that when it goes live, we'd love to get comments on. So I think this is like going to be the meat of what we should be discussing, which is what are all the problems that we found? What do they feel like? What do they mean to us? So first things first, the supply chain is horrible. People say download this zip with this hash, it's the node. It's either through GitHub or it's through SourceForge or it's through some just random site, a website that you go to and download it. If you go back to the previous comment that your node is your view of the world and you're downloading an arbitrary piece of software that you can't validate, what are you actually like operating against? Especially when you become a big player like a large exchange, like you start to worry about these kind of supply chain problems because it'd be trivial, not really the right word, but an obvious attack vector is to subvert the node, subvert the wallets. Our view of the world is completely different. We're spewing money, for lack of a better term. And also, it's showing no signs of improvement. This is part of like the distributed nature of some of these crypto blockchains. Is there's no real desire for centralization. People don't want to be tied down to a key authority. When you don't want to tie down, how do we get any kind of consensus about how we should publish this software, where it should go, how should you validate it? Next piece, security response and communication stuff. A little shout out to Dan for the work he's doing on making it at least possible to find where all of the exchanges are. But at the end of the day, we asked like dozens of asset issuers, how will we find out if there's a vulnerability in your node, in your wallet, or in your smart contract? The common response was, here's our Telegram channel, just sit there and watch for it. And I'm like, you get the hell out, right? Like, I can't do that. The other response was, we haven't thought about that. Thank you for bringing it to our attention. The last response was like, I don't know what you're talking about. It's been audited. Like, that's not how this works. So, you know, as an exchange, it matters a lot for us to know if and when we need to shut down a given asset, right? Like, that's our users' trust that we're dealing with here. If they're sending money in, or if money is for some reason leaking out and nobody's telling us why, no amount of investigation we're going to do internally is going to point us at that until like the last step. This is like a reiteration of the open source software problem. Like, it's open source. A lot of the bugs are out there. If you're not paying attention to what needs to be fixed, you're not going to look at it. You're just going to miss it. That third piece is the specs and the implementations were often very different. This caused a lot of problems. In some node implementations that we're looking for, like none of the test cases passed. And that was like the node implementation we're supposed to use. In others, they passed in ways that were just counterintuitive to what the protocol specified. End of the day, right? Like, if you can't trust what the software is like going to do, how can you even bother to support it? Yeah. So smart contracts. I have a lot to say on that, and I think I'm going to take the rest of the time to actually talk about that one. The one thing that a lot of people kind of gloss over when talking about some of these smart contract systems is the concept of ownership. At the end of the day, most of these contracts have a single point of failure, and that's the ownership key. That key can often allow for upgrades. It can allow for arbitrary changes in internal contract. It can call like special admin functions. If I think about things that I worry about, it's saying that I have not seen any transfer events on a smart contract in ERC20 that lead me to believe the balances should be different, yet the balances, when we check for them, are different. A very easy way to think about that is an admin has invoked like a transfer and like kind of rewritten the internal address book, or sorry, the balance book. That sucks. Like, that is something where we have to build lots and lots of instrumentation around the blockchain itself, looking at contract calls to see, has an admin been compromised? Has my laptop fallen asleep? So what does that mean when it comes to like custodiability? There is an entire layer of key operations, like literally the people who wrote the contract, what do you do and how do you manage your private key, that is just completely outside of the scope of any of the audits that people are doing these days. You look at how many things are kind of operationally relevant to this particular contract, and if and when they're operationally relevant, what do you do with them? How do you make sure that this upgrade that I see is not an indicator of compromise of your private key, but it's an expected action? And that's my login screen. And so what that means for us is the more of these kind of special fancy actions, the more complicated any given smart contract system is, the less that we are comfortable with its ability to like be good, especially when you throw in like kind of wrapped proxy calls to upgrades or set implementation calls that are hard to pull out. There's also like a second layer on this, which is Geth and Parity do not make available the ability to really look at kind of contract calls as they're happening. You have to go deep inside trace logs, rebuild the AST, and figure out what's happening. Also means that every time you do that and then the EVM changes, you're looking at a whole new world. Let's see. My gripes on contracts are almost done. So the bit of information that you will not get from any of these contract developers is who has the private keys, how are they stored, how many times do you expect them to be used, and will you tell us before any kind of expected use? You'll get this if you have like a very strong one-to-one relationship with the people who actually built it. In the general sense, you're left at the mercy of what the contract allows. If the contract pushes an upgrade that completely wipes the books of Coinbase, we're on the hook for that, right? Like we're responsible to our users about what ownership is. There's no way that we can really separate and kind of get away from that problem. On the other hand, the contracts are only considered utility tokens if they have utility, which means they need some degree. And for those of you who are smiling, you probably know the difference between a security and a utility. And the argument that's been made that if a token does not have any other utility, it's a security. Therefore, a lot more law and legalese around how and where you can use it. But yeah, if there's utility, it's way harder for us to maintain custodiability. If there's no utility, then you have to be a registered trader or like a registered investor, authorized investor, to be able to actually use it. What was the last note that I had up there? Did anybody catch the last one? Yes. So the last bit of information that's derivable but not necessarily true is for these proof of work type systems, how much hashing power is actually out there? A lot of the consensus algorithms say like, this is fine unless there's a 51% attack, Byzantine generals, so have you. However, if you don't have a good way of guessing how much hashing power is potentially available to either power or secure the chain, or to subvert from other chains to drive against insecurity of the core chain, you don't know how many confirmations you need before that chain is relatively secure. There's split opinions even on my team about whether ASIC resistance, so dedicated mining hardware resistance, is actually something to be strived for any kind of cryptocurrency. The easier it is to hash against it, the more likely people are to hash it. Therefore, the more likely it is to be secure. However, there's less likely, for resistant chains and resistant algorithms, it's less likely that they can be subverted just because there isn't as much hashing power available to it. You add in the fact that some currencies start sharing SHA function types and kind of like the hashing algorithms, then you can say that I can point BTC against BCH when the time is right and execute an attack. How do you know if hashing power has died down on a given chain because it's not profitable versus somebody's taken it offline to start executing an offline attack, and as soon as the time is right, we'll start publishing it? For us, there's not much we can do about that. We can take some inferences when it comes to what is relative hashing power, what is the difficulty factor, right? How long will it take for a new block to be generated, and try to make some guesses about what confirmation should be, whether confirmation should change. But if you're the slowest person in that race, the bear's going to get you. And the bear in this case is a 51% attack. End of the day, though, it mostly harms our users through us, and that's why we don't want to support any of it. I've kind of whirlwind through a lot of the things that we care about and things that we look at. There are more subjects that we'll kind of dive into, but particularly one thing I'd like people to ask questions about is what should we do about smart contract security? What should we do about all this layer 2 level, admin level stuff that dramatically alters the ability for any large custodian, obviously, but also small custodians, people, to maintain the funds that they think they've bought. I can take some answers on our key management stuff and cold storage and what we do in the deep back end, but I'll give you bad answers for the most part and run you in circles if you ask too deeply. My last slide said, thank you again for giving me the opportunity to kind of rush through all the things that make me paranoid about adding new assets to a platform. It also reiterates that somebody please click on coinbase.com/careers and give me some page views there. Otherwise, I'm not coming back, which might be fine. But overall right now, questions. What's interesting to people?
I was curious if you all thought about open sourcing some of those monitoring softwares you've built in-house for looking at smart contracts and the usage of them.
We've looked at some of it. For a lot of our use cases, we tend to build in-house just because the quality of the open source tools won't scale to the number of transactions or kind of the amount of data we need to push through it. Is that helpful?
I got a question for you. So security firms have this enviable position of being in direct contact with the development teams that we work with, and having the time to deeply study the code bases that end up getting deployed. What is one thing that security firms could do that would make your life a lot easier? It sounds like you have a big list of wants and needs, and you're actually looking at and reading some of the publications that come out. So what's missing in your eyes?
A lot of this comes back to the admin level of complexity and then the operation controls that team has implemented to make sure those keys don't get compromised. Nobody really talks about it. Nobody wants to audit it because it's hard and not well solved. But at the end of the day, like this report is fine. The code is fine. Even if you have like the base Open Zeppelin ERC20 and no additions to it, but you lose the key, like it doesn't matter anymore.
Everything's fine, but the key's on this guy's laptop, and it's shared to a file share that 50 people have.
Yeah, it's basically that. Or it's on a Ledger Nano, and if they ever, like, if it breaks, that's that. And so both secure storage and secure backup of keys is a complete pain in the ass.
Cool. Thanks.
Just had a quick question about the security framework in relation to a lot of tokens that have recently been listed. How does Coinbase factor in potentially if a team has access to freeze the actual assets or there's an escape hatch in the actual contract?
I can barely hear you.
I'm sorry. With the security framework in relation to the tokens that have been recently listed and to be listed, how do you guys factor in if there's an escape hatch or a freezing function that a team can deploy who are still in control of the token?
We just add it up in terms of total complexity, right? Like if we're making this, so the goal of the report is to make it easy for a lot of our kind of internal executive like leaders to look at. We just flag where complexity is and how complexity comes from. So it's not just like these kind of freeze functions, but like anything that stops transfers immediately affects our ability to move money around. So like there's not much we can do except for monitor if and when it happens and flag that this is a thing we have to monitor for and build kind of the DR pipeline for dealing with it. DR is detection and response.
So you said a few people on your team are split on the question of ASIC resistance. I'm just curious what side you fall on and why.
So this is a really tough one. I am pro ASIC, mostly because my mental view of the world is there will be many, many currencies, then there will be many few currencies. And so when I say, sorry, many few, there are many fewer currencies. So when we're down to a world from like hundreds of crypto, everybody's kind of rolling their own Bitcoin fork, to there are like 3 or 4 main currencies that people support. Having ASIC support is going to be like, it's going to be great. There's not things to attack. Let's make it as efficient as possible. I am, however, completely against proof of stake that requires the currency moving keys to be hot the whole time. The only reason I get to sleep at Coinbase is because 99-ish% of our funds are in cold storage at any given time. If you're making me bring those live so I can stake every 15 seconds, my whole security model has gone out the window.
So a relevant question, what about a model where you had like a delegated key for staking that could be live and then that could expose some user funds to slashing, but not all? Would you guys be legally comfortable with that kind of exposure, or is that still a no-go?
Like I'm the security guy, right? So any additional exposure with like unknown benefit, or rather non-direct user benefit, makes me uncomfortable. However, like the way I mentally think about this is that's basically like what a money market account does. It exposes funds to some amount of risk for small amounts of return. We should be able to model it out financially, kind of how much potential exposure are we giving to any set of keys, with the assumption that any keys we expose, it's just like half time until loss. And then say like, what can we stomach? What is the trade-off here? If it's not worth staking within that, like kind of what we can stomach, then we're not going to do it.
Cool.
Hey, I'm curious why you specifically called out the quality of a wallet, because I just imagine everything that Coinbase is doing is through APIs and your own automated processes. Are you, you know?
So there's like kind of 2 core reasons. One, a lot of our users tend to use the wallets to send money to us, and there's no way for us to debug whether the user like did it wrong. In fact, some of like the worst cases are users sending us their private keys to say, hey, can you go log into my wallet and look? I'm like, no, please no. Like, I don't want that, right? The other piece here is it's a sanity check against any code that we're writing internally, right? If we're writing our own accounting systems or writing our own kind of integrations against the node to see like this is a transfer, it's been signed and so forth, we don't have integration tests otherwise, right? And if the wallet's not good, if there's no test cases that we can reuse, we're kind of stuck up a creek.
Thanks.
This question over here.
So how formal is this framework? So take the wallet quality example. Do you have some number, or is it more of a subjective, like someone reads the code that's available and makes a subjective opinion, and then that goes into the report?
We're objective about creating what we want to look for and subjective about reviewing it. Unfortunately, like the population size isn't huge here. Particularly in some of the like less popular currencies, there's a wallet and a node. We have no kind of reference point against each other to say what does something better versus worse. With that said, our goal is to be as objective as possible. However, like that's like trying to build a static analyzer. Like at some point, it's going to fail and it's not going to be any good. We just kind of draw the line and see what's stomachable. I will say it's a really nice Word document, and so it's like well designed. It's got colors and like reds and yellows and greens. It looks super pretty when you're just kind of looking at the cover page and you see like risk rating, risk scoring, and whatnot. So like that part, super objective.
I have a question. So over here again to your left.
Oh, hi.
You were talking about multiple nodes earlier. In currencies that do have multiple implementations, do you guys run all of them? And do you find it helpful for a currency to have multiple implementations or harmful?
I won't guarantee whether we run all of them. In some currencies, we definitely run multiple. And it's been extremely useful as like kind of a check against the other node, particularly when there are any kind of upgrades to the node. Yes, I would love multiple competing implementations for all of these nodes. However, I do realize that some of like as you follow the curve of popularity of these new blockchains, there's like a developer who part-time is writing like the one node and the one wallet. We're not going to find multiple implementations. But like the parity bug that I was talking about, we noticed because our two node systems were just clashing with each other, and that should never happen, right? And so that's immediately like, hit the big red button, pull all of the stops, and say, wait a second, that was only in testnet. Turn everything back on, but don't upgrade right now. Great questions, y'all. Keep them coming.
I was just wondering, you were talking about, being custodian for all these different tokens, and I was wondering when you were talking about the smart contracts and not being sure of the keys behind some of those and the exposures, whether you have custodial services around smart contract keys, and would that be any different than the tokens?
So my buddy Alan over here can sell you our custodial services if you're big enough. But roughly, yeah, we do offer that because one of the core things that Coinbase does is we store our own private keys. We spend a lot of time and money designing a system to be like resilient and robust and just enough of a pain in the ass without being too much so, while also not exposing us to kind of kidnapping and ransom type risks and so forth. It's a huge trade-off, right, at the end of the day. Not really. It's a key management service. What really matters is responsibilities for the different key actions. And so if the contract just requires the owner key to do anything that's of administrative value, like that key is going to be online as often as you need to do one of those things. That to us is a huge signal of like, that's risk. That's the risk that's accumulating every time they bring that key online to use it, because it's not like they're rotating the keys afterwards. All right, thank you all.